Graphing linear inequalities in two variables. All right, so today we're going to determine whether an ordered pair is a solution of a linear inequality in two variables. We're going to graph linear inequalities in two variables, and we're going to interpret solutions of a linear inequality in two variables in a real-life situation. All right, vocabulary that you need to know. A linear inequality in two variables. X and Y can be written in one of the following forms where A, B, and C are real numbers. AX plus BY is less than C, AX plus BY is greater than C, or AX plus BY is less than or equal to C, AX plus BY is greater than or equal to C. So as you can see, these are in standard form, but they have an inequality sign instead of an equal sign. So that's what makes the inequality. A solution of a linear inequality in two variables is an ordered pair that makes the inequality true. The graph of a linear inequality in two variables shows all the solutions of the inequality in a coordinate plane. The boundary line divides the coordinate plane into two half planes. The shaded half plane is the graph. All right, so this is just an example, y less than 2x. You can see that because it's less than, it is dotted. If it were less than or equal to, this would be a solid line instead of a dashed line. And then everything below that line is shaded because this is y less than 2x. So that's just an example of a linear inequality. All right, let's look at some examples. All right, example 1, we're going to check solutions. Tell whether the ordered pair is a solution of the inequality. All right, so it gives us 2x plus y less than -3, and it gives us an ordered pair of -1, 9. So to check it, we have to plug in our x and our y value and see if this is a true statement. If it's a true statement, then the ordered pair is a solution of the inequality. All right, so let's change this here. All right, so we have 2 times x. X in this case is -1. And then plus y, y is 9. And we want to know if that's less than -3. So 2 times -1 is -2. -2 plus 9 is 7. Is 7 less than -3? No, 7 is greater than -3. So that is false. That's not true. So -1, 9 is not a solution. So we can say this one is not a solution. All right, let's check B part. B part has x minus 3y greater than or equal to 8. And it gives us an ordered pair of 2, -2. So that's our x and y value. So x is 2 minus 3. Y is -2. So plug that in. We want to know if that's greater than or equal to 8. So we have to multiply first. So 2, we've got -3 times -2 is going to be plus 6. And 2 plus 6 is 8. 8 is equal to 8. So is 8 greater than or equal to 8? That one is true. All right, so this one was not, this one is. So 2, -2 is a solution to the inequality. Okay, example 2, graphing linear inequalities in two variables. All right, this one says to graph y less than or equal to 2 in the coordinate plane. So we need a different color here. Let's go with black. All right, so first we have to find y equals 2. So go from 0, go up 1, 2. And we know we're going to have a solid line across this y equals 2 line. So let's get a line here. All right, we are going to have a solid line, and we know that because this is less than or equal to. We're also going to have the shaded region is going to be facing down. So everything, well, that's not what I wanted. Let's see. Everything facing down is going to be included in the shaded region. So this whole area here will be the solution area. So we can take the highlighter and we can shade everything below y equals 2. So I'm trying not to get above that line, but everything below the line would be included in the solution. All right, and you need to know if you graph this correctly. You can just choose a point. 0, 0 is an easy point to plug in. There's no x, so you just plug in 0. Is 0 less than or equal to 2? The answer is yes. So you know that you did graph this and shade it correctly. Example 3. All right, I want to graph negative x plus 2y is greater than 2 in the coordinate plane. All right, so this is in standard form. Let's quickly put this in slope-intercept form. It'll make it a little easier. So the first thing I'm going to do is add x to both sides. So I'm going to have 2y is greater than x plus 2. And then I'm going to divide by 2. So I'm going to have y is greater than. I can write this as 1 over 2x, 1/2 x. And then plus 2 over 2. Anything divided by itself is just 1. So this is an equivalent equation. So this is going to be slope-intercept form. So I know that I'm going to go up to 1. And I'm going to put a point here. And then I'm going to use my slope to rise 1, run 2, rise 1, run 2. You also can go backwards, so you can go down 1, to the left 2, down 1, to the left 2, however far you need to go. All right, let's choose. This time we need a dotted line because it is greater than, not greater than or equal to. All right, so now that we have our boundary line, we know that everything above this line would be part of the solution set. So I'm just using the arrows to show you which way to shade it. So y greater than is above the line. So again, I can use my highlighter and I'm going to use everything above the line. This time the points on the line, the boundary line is not included. That's why it's a dotted line. So the boundary line, those points are not part of the solution. Everything else above the line would be part of the solution set for this inequality. And I'll try to get a little bit closer, try not to hit that boundary line, kind of hard. All right. All right, again, you want to choose a point to plug in to see if you graphed it correctly. 0, 0, you can see is not a good point to choose this time because it's below the boundary line. So you have to choose a point somewhere in the shaded region to see if it makes this a true statement. That will tell you if you graphed it correctly or not. So let's choose a point, let's say over 1, up 1, 2, 3, 4. So let's choose 1, 4 as a random point just to check our solution set. So if we choose 1, 4, and this is just to check it, 1 is our x, 4 is our y, so we can just plug it in to check it. I'm going to come down here and say 4, is that greater than 1/2 times 1 plus 1. So is 4 greater than 1/2 times 1 is a half plus 1 is 1 1/2. Is 4 greater than 1 1/2? It is. So we graphed, that just gives us a confirmation that we graphed this correctly. All right, a study tip. It's often convenient to use the origin as a test point. However, you must choose a different test point when the origin is on the boundary line. Okay, so if you remember, I checked 0, 0 here. 0, 0 is below the line, but if it were on the boundary line, we still could not use it since this is a dotted line or a dashed line. All right, self-assessment. I want you to take a few minutes, pause the video, see if you can graph these inequalities on your own, and then answer this question as well. When determining which half plane to shade in the graph of an inequality into variables, why is it important to test a point that is not on the boundary line? All right, so when you have an answer for these, just come back and we will look at them together. All right, hopefully you took time to graph these on your own and you can see if you did okay. All right, so graph the inequality in coordinate plane, y greater than -1. All right, -1 is 1 below the x-axis. It is dotted because it is just simply greater than. So everything above that is greater. So you should have picked a boundary or picked a point somewhere. 0, 0 would work in this case. 0 is greater than -1, so you can easily see that that works. All right, B part says x less than or equal to -4. So you come over to x is -4. You graph that line as a solid line because it's less than or equal to, meaning the points on the line are included in the solution. And then everything less than or equal to that line is part of the solution. Choose a point, test it, choose anything like x is -5. So say -5, 0. -5 is less than or equal to -4. That's true. So it's easy to check that if you take time to do that. All right, when determining which half plane to shade in the graph of an inequality in two variables, why is it important to test a point that is not on the boundary line? All right, so here's a simple answer: because a point on the boundary line does not show which half plane to shade. So hopefully you got those correct, and we will come back shortly with a real life example.